Okay, that's the easiest I've ever gotten something set up at one of these conferences. So hi, I am Andrew Clark, or AC Delight on Twitter and GitHub. I work on the React core team at Facebook, and I'm here to talk about React. So for those of you who don't know, React is a JavaScript library for building user interfaces. Is that news to anyone in here? No? There was a time when half the room would have no idea what I was talking about, so it's actually quite nice to give a talk now where most people already know what React is. Here's a fun fact. React turned 5 years old earlier this year. That's kind of shocking to me. I know we're not as old as some of these other frameworks, but it still feels ancient in JavaScript. That feels like a zillion years in JavaScript years. Like I said, I've given a lot of talks about React. I think the first one I gave was back in 2014, and things were really different back then. Like I said, most people in the audience had never even heard of React. And once I did tell them about it, they weren't exactly instant fans. In those early days, it had this thing called JSX. It was just kind of weird. React was weird. It had this thing called JSX, which involved putting XML syntax in your JavaScript. It mixed presentation and behavior, which you absolutely should not do. It had something called a virtual DOM. Who the hell knows what that is? It didn't have two-way data binding. How are you supposed to be productive if you don't have two-way data binding? It was just weird. So those early talks are really mostly devoted to me just convincing the audience that this React thing was something they should even bother learning about, let alone actually use. A lot can change in 5 years. Some people still don't like JSX. That's a little bit the same. But a lot of the parts of React that used to be weird and novel are commonplace across a lot of these other frameworks that we're going to learn about here today. We've also gained quite a bit of adoption since then. Did you know that Microsoft is using React in Office? This is still mind-blowing to me. I don't even think it happened that recently. Yeah, so React is not that weird anymore. In fact, you might even say that React is boring, maybe. Again, Microsoft is using React to build Office. So clearly, somewhere along the way, we passed an inflection point from weird to boring. I'm teasing, of course. I love Microsoft. I love VS Code. But I do think there's something to this idea that React has become quite ubiquitous. It's become the framework against, for better or worse, a lot of these other frameworks are compared to. And that has its pluses and minuses. So I'm really excited to be at a conference that is about figuring out how the different frameworks can learn from one another, even more than we clearly already have. So I've decided to organize my talk today into kind of, I was struggling a little bit with the outline of this because I know not everyone here is a React developer. I don't want to assume knowledge from anyone, and I want to try and keep this high level enough that it's interesting. So I've decided to organize it into 3 topics. It's a little different than how I usually do things. And these are areas where I believe that React has made decisions as a framework and as a platform that decisions or trade-offs that I think distinguish it from the other frameworks. So the 3 that I could talk forever about this, but I think the 3 that I want to talk about are one is that React uses JavaScript instead of templates. Another one is that React has really strict ideas about enforcing immutability instead of allowing a more like mutation-based API. And the third topic is that we have really focused on keeping a small core UI, or core API, I should say, and deferring things quite often to user space, to the open source community, as opposed to providing these off-the-shelf, ready-made solutions like you might find in a more traditional framework. So let's go into this first topic, using JavaScript instead of templates. So React does not use a templating language. It does not have its own templating language. Instead, you treat the UI as data and you manipulate it with JavaScript using the exact same language features that you'd use to manipulate any other kind of data. There are a lot of nice things about using a full-featured programming language to build UIs as opposed to templates. One is that you don't have to reinvent features that already exist in your host language, right? If you need to render a list of elements, just use array.map, use a for loop, use a while loop if you want to. Need to render, you can use recursion. If you need to render a component conditionally, just use an if statement, use a ternary. These aren't new concepts if you've been a programmer for a little bit. In contrast, like templating languages, if they want to do these types of things, they typically have to add their own versions of things like loops and conditions and these other programming language constructs in order to express common UI patterns. But ultimately what you're getting is a more constrained, some might say worse version of an actual Turing-complete programming language. Another way of saying this is just that JavaScript, the advantage of it is it's more expressive than a templating language. Another thing is with templating languages, it's just more you have to learn. Not only now do you have to learn JavaScript, you also have to learn this other like pseudo type almost language thing. So just more things you got to keep in your head. Whereas if you know JavaScript, which you likely do, or you probably have to learn it regardless if you were going to build web apps, then that's just the one thing that you have to learn. Of course, there's trade-offs. It's not perfect. And the main one is that JavaScript is a lot harder to optimize than a constrained templating language, right? So projects like Svelte, which we're going to hear about later today, those are really exciting. Svelte is really, I think it's given us a taste of what's possible when you can use advanced compiler techniques, build time optimizations for your user interfaces. It has like a huge impact on things like initial render, update performance, and stuff like that, bundle size. So we would like to do similar things for React, the stuff that Svelte is doing, but because we rely on JavaScript, it's a lot harder for us to do those types of things. We'd have to be able to optimize the entire language in all of its complexity, not just the constrained complexity enforced by a templating language. So that's actually exactly what we are planning to do. We have this experiment, this project called React Fusion. It's a kind of offshoot of a larger project called Prepack, and the idea is to teach the compiler about React semantics and about the React runtime in order to enable these advanced compiler optimizations. For example, React Fusion will have the ability to inline, if you have like a large component tree, React Fusion will be able to inline multiple components into a single component, giving you like zero cost abstractions essentially. And this is a long-term project, but if we're successful and we're able to make this work on in React that uses JavaScript for its UIs, we think the payoff is going to be pretty huge, and we'll get a lot of the same benefits and maybe more that a framework like Svelte can currently get, but maybe without sacrificing the expressiveness of a Turing-complete language like JavaScript. Okay, so next topic is immutability. React really favors an immutable paradigm. And that's one of the first things you learn about React is that props and state in React are immutable. That means you're not supposed to update them or mutate them directly. Instead, if you want to update your UI, you call this special method called setState, and that's how you do things. There are a lot of nice things about immutability, which I'll get to in a bit. But there are also a lot of things that are like not that great either. It requires additional discipline by the developer to follow the rules and try and avoid making accidental mutations. And even if you do have the discipline and you follow the rules, the resulting code is, arguably less ergonomic than you would get if you were able to use mutation instead. The way, like, for instance, Vue is able to do that with their reactivity system. So here's a classic example. In React, if you want to update a value that depends on the previous value, you need to pass a function to setState, which like turns the previous state into a new state object. And it's not that bad in practice, but like if you compare it to the mutation version, like why can't I just do it like this? Why can't I just use the incrementer to increase the count? There's boring reasons, technical reasons I can give you for why we enforce this in React, but if you're a developer, maybe you don't really care. So I think for a lot of developers, this part at the bottom is a much more familiar API and it's more idiomatic to JavaScript. Having said that, there are a lot of nice things about immutability, and there are reasons we go through this extra trouble to enforce this constraint, and that is that it enables us to it unlocks some really clever things with how we process updates and schedule rendering, things that the user, for the most part, never even needs to think about. And a lot of those benefits fall under the umbrella of a project called Concurrent React, and then also React Suspense. We used to call Concurrent React Async React. We found this was confusing for people, so we've now switched to Concurrent. I don't know if that's less confusing, but we'll see. Unfortunately, I could spend, again, forever on just this slide. But the gist of this is that because React's rendering phase already has the constraint that it must be free of mutations and side effects, this allows us to render multiple updates concurrently. So under the hood, we're using this fancy double buffering architecture. That means we have like an asynchronous render phase. And then once all of that is complete, we have a synchronous commit phase. And that means we can start rendering a tree without actually painting anything to the screen until the last piece is finally locked into place. And then we can commit the whole thing and guarantee consistency without tearing. A lot of blah-bitty-blue, but it's cool stuff. Now, all this cool stuff, we could implement a version of it if we didn't. We can implement a version of this concurrency if we allowed some sort of mutation type API. But it's a lot easier, and we can do a lot more sophisticated types of scheduling, for instance, putting things on totally separate threads, if we have these constraints for where mutations and side effects are allowed to take place. And so kind of the third umbrella of thing I wanted to talk about is React's approach to API design, which I also think in some ways is different from the way these other frameworks have approached API design. In some ways, it's the same. So we've always had a very small API surface area, and we've always been very careful about adding new features. Does anyone remember back in like 2015? I can't remember when it switched. React used to, if you went to React, the React docs, the first thing you saw was React, the V, and MVC. Does anyone remember this? Kind of clever back Trojan horse marketing right there. That's clearly not how people use it nowadays. But that is kind of like the origin story for how React came to be. Is like it's this very focused thing that's meant to do one thing really well. It's not meant to replace your entire application architecture. And so we've always kind of taken some version of that approach where we keep the core API really small and we leave user space to create these frameworks like Apollo and Relay and Redux and React Router and all these things on top of React that provide more of the frameworky type of architecture that you typically find in a framework. So the reasons for this are myriad. One is that it helps with stability. So because we have a small surface area, we rarely need to make breaking changes, which is really important for Facebook in particular because we have 50,000 components of varying levels of quality. It's just not acceptable that we make breaking changes to React all that often. And whenever we do, we have a really solid incremental migration path, often supplemented by things like automatic code mods and stuff like that. Another reason is it just allows us to leverage the innovative power of the React community, which has always been very vibrant, even in the early days when there weren't that many people using React. The truth is, if 5 years ago React had released an official router or an official data fetching solution, it would have been a lot worse than what the community was able to focus on and iterate on themselves, because we have limited number of people and limited number of things that we can focus on the React team. It's really nice being able to rely on the community to fill in the areas where there are gaps. Of course, again, downsides as well as to this approach, especially before things like Create React App existed, things like Gatsby and Next.js, which I think are really cool. As a React developer, you're just faced with a lot more questions and uncertainty about the best way to architect your React apps, as opposed to, say, if you're an Ember developer, where a lot of those decisions are just made for you, right? So here's the thing. 5 years ago, we didn't really know that much about building React apps, right? The React team didn't know that much about building React apps. It was still new, even to them. And we didn't really offer advice about architecture because we didn't necessarily know what the right trade-offs would be. And we imagined like there's not going to be one type of React app. Some people are going to embed React inside of another system. That's the way Facebook used it or still uses it in its newsfeed. Some people are going to build single-page React apps, and they're going to have an entirely different set of constraints. But now it's 2018, and we think we actually do know a lot more today about how to build good React apps that cross-cut across all these different users of React. So I think in the future what you can expect is that React will continue to keep a small, focused core API, but at the same time we also want to make it as easy as possible to build idiomatic React applications. So I think you're going to see us add new core APIs to help with that. One example is the context API that we released earlier this year. So if you're not aware of this, previously, if you wanted to share data across multiple parts of your application, there was no official React API that wasn't totally broken that let you do that. So in practice, people would reach for these third-party libraries, and a lot of times those third-party libraries for things like Redux, even though Redux isn't necessarily the best option or specifically designed to fill this use case, like say all you want to do is share the current theme across all of your components. You shouldn't need to pull in Redux in order to do something quite like that. So the new context API gives us a better way to do that. Another example is this thing that we just merged a few days ago and will be in the next release. It is, oh, shoot, I went too far. It is a first-class API for code splitting in React. It's built on top of React Suspense, if you know what that is. And it works such that the component won't be fetched until the first time you attempt to render it. So now you can just opt into code splitting without changing how, but just by changing like a single line, which is how you import the component. If you're familiar with React Loadable, it's very similar to that concept. I also believe Vue has a, not exactly similar, but a similar way to just like change a single line and make the component lazily imported. Of course, it's built on React Suspense, which is not previously possible in user space. And I think there are going to be some large advantages of building these types of APIs directly into React going forward, not just to provide tighter integration with React, but also they're important use cases, and we want to make sure people get them really right. And we want to encourage their adoption in the community. Okay, so it's a lot of higher level stuff. I wanted to make that kind of useful for people even if they don't know React very well. This last part, I'm just going to regurgitate a bunch of stuff that is coming in the next few versions of React without explaining it too much, just so you know just so you have an idea of what's coming, and you can ask me questions later. So there are a lot of things I haven't even mentioned. So one thing we were working on recently is a React performance profiler. It actually just came out, I think like 2 weeks ago in React 16, whatever it is, 5 or 6, whatever version it is. That's really cool, really exciting. It's going to make it a lot easier to analyze the performance of React components. React Lazy, the thing I just talked about. There's React Pure, that's bringing memoization to functional components the same way memoization currently exists for class components in the form of Pure component and Sure component update. We have the same thing, but now for functional components. An opt-in API for concurrent React. That'll be coming in the next release of React quite soon. React Suspense. We've been talking about this for quite a bit this year. Probably the first way that you'll use that is via the React Lazy API. That's going to be in the next version of React. Scheduler. I didn't even really allude to this, but I talked about it a lot yesterday at the Creator Summit. This is a package for making main thread scheduling, for improving main thread scheduling. Mostly meant to, or a lot of this will be is designed towards frameworks, but what we've basically done is lifted a lot of the really cool scheduling capabilities that we put into concurrent React. We've lifted that out into a generic main thread scheduler. We've been working really closely with the Chrome teams, and we're hoping to work really closely with the other frameworks to like iron this out a little bit. And we'll be releasing that pretty soon as well. And there's other things like React Cache. There's just so much more that I've barely even gotten to. And fortunately, React Conf is at the end of this month, and you'll get to hear about a lot more there. So if you have any questions, I kind of skimmed over a whole bunch. Just please come up to me later today and tell me what you think. And I'm looking forward to meeting all of you. So thank you.